Okay, so this is the other section that we're going to do as if we were in class uh, for the session, and it's section 5.4, irrational numbers. Okay, so irrational numbers are numbers that cannot be written as a fraction, and where you see most of the time where that we use an irrational number is when we do the Pythagorean theorem. So the Pythagorean theorem finds a missing side of a right triangle, and because everything's squared, we take the square root of something, and once you get the square root, a lot of times you get an irrational number. So that is why it's widely used and why we really study irrational numbers. Okay, so an irrational number is a real number that cannot be written as a ratio. So it doesn't repeat and it doesn't terminate. It just goes on, but it doesn't have a pattern where it was repeat. So it can't be written as a fraction. So the principal square root, and that's what this symbol means, that's the radical, is what number times itself can give you the number under the radical. So in this case, square root of 9 is 3 because 3 times 3 is 9. The square root of 36 is 6 because 6 times 6 is 36. That's what it means to take the square root. So this symbol is called the radical sign. The number expression inside is called the radicand. So there are, certain numbers that are perfect squares, and those are the ones that we use most often. And here's a small little short list, but I'm going to give you all of them because it's important that you know that the square root of 4 is 2, that the square root of 9 is 3, the square root of 16 is 4, square root of 25 is 5, square root of 36, 6, square root of 49, 7, square root of 64, 8, square root of 81, 9, square root of 100, 10, square root of 121 is 11, and the square root of 144 is 12, and usually about as far as we go is 13. So that's important to know. So the reason I kept it like this so that I could show you my calculator. So my calculator, if I went to and got the radical sign and I put in a perfect square, I will get the number back. But if I put in a number that is not a perfect square, then I get this big long decimal. Now it's terminating only because my calculator is running out of room, but that's an irrational number. As soon as you see a decimal, that's an irrational number, whereas the other ones are considered perfect squares. Okay, a number that multiplies a radical is called the coefficient. So this 3 here is called the coefficient. Okay, that's the number in front of the radical. So that would never, that would never go underneath, all right? So it would never become radical 15. That's always stays out front because in order to multiply, they both have to be radicals. So if they're both radicals, then you can multiply them together. So radical A times radical B is radical whatever A times B is. And that comes into play when we want to what we call simplify the radicals. It's almost like reducing a fraction. We're putting in simplest form. So you write the radical as a product of two radicals. One of the radicals should contain the greatest perfect square. That's the key. That is a factor of the radicand in the original. Then simplify the radical containing the perfect square. So if we want to simplify radical 80, that is equivalent to radical 9 times 2. And we do 9, like the reason we don't use 6 and 3 is because we want a number that's a perfect square. So it's got to be, one of them has to be a perfect square or you're not doing it. So the square root of 9 is 3, so our final answer, it's simplified, is 3 rad 2. So same thing for radical 80. If I have radical 80 and I simplify it, I get radical 16 times 5, because 16 times 5 is 80. The square root of 16 is 4, so simplified, the answer is 4 radical 5. Okay, so you wouldn't do it with a number like radical 10 because there's no perfect square that is a factor of 10. You only do it if the number has a factor that is a perfect square. Okay, you don't just do 5 and 2 because neither one of them were in that list that I just made for you. So let me try a couple others. So let's say, now I always do it like this. So let's say I wanted to do radical 20. So I'm going to break it up into two. So one of them has to be a perfect square. So it has to be radical 4 and radical 5 because 4 is a perfect square. The square root of 4 is 2, and it's 2 rad 5. So we always put the perfect square first, so it comes out of the radical, and the second one always stays underneath because nothing happened to it. So let's say I want to do radical 27. So that would be 9. Always put the perfect square first, and 3. Square root of 9 is 3, and the second one always stays under. Let's say I want to do radical 200. So that would be 200 because that's the perfect square, and 2. And this would be 10 radical 2. You always have to make sure you get the largest one, though, because like 48, 4 is a perfect square in 48, but 16 is the largest one. So you have to make sure that you take out the largest one. So you start dividing, if you're not sure, from the list of that I gave you on that other slide down. So like from 100 down, you would start dividing and seeing which one is the largest one that goes in. Sometimes there might be a coefficient in front, so like let's say it was like this. So we kind of ignore the 3 for a minute. We do this. Okay, so 75 is going to be 25 and 3, because 25 times 3 is 75. And 25 is perfect square. The square root of 25 is 5. Then we take this and we multiply those two. And so our final answer is 5 radical 3, because we have 3 of them. So you ignore it in the beginning, and then you multiply it at the end. So let's say I have 2 radical 50. So again, I simplify radical 50 to radical 25 radical 2. This is 5 radical 2. And again, at the last minute, when I write my answer, I multiply those two, and I get 10. And it doesn't matter, even if it's negative, even if it's a fraction, I do the same thing. So this would have been 9 and 2, which would have been 3 radical 2. Then I multiply these two, which is negative 1, so I just write negative radical 2. Okay, so that's simplifying the radical. So again, that's not something you could do in your calculator, because so if I put radical 20 in my calculator, because it's not a perfect square, it's an irrational number, and so it's not something that you can do in your calculator. You have to know how to simplify it. Okay, so if I want to add and subtract radicals, they have to have the same radicand, okay? Almost like fractions have to have the same denominator, and then we just add the coefficients. Okay, so I can't subtract 5 radical 3 minus 12. I could do it if they were the same radical, but I can't. So what we do is we simplify just the second one because it doesn't matter about the first one. So we make that radical 4 radical 3, so this becomes 2 rad 3, and then we subtract the 5 minus 2, and our final answer is 3 radical 2. So you have to simplify it first, okay, before you can subtract them. So I just want to show you that if you did have the same radicand, so like let's say I have 5 radical 3 plus 2 radical 3, they're both radical 3, I can just add them, and I get 7 radical 3. I add the numbers out front. Let's say I had 6 radical 5 minus radical 5. So even though we don't write it, by convention, there's a 1 here. So 6 minus 1 would give me 5 radical 5. And that would be my answer. But if I get radical 6 plus radical 54, okay, now I can't add it. Just like the fractions before. Could add it when it had the same denominator, can't add it when it doesn't have the same denominator. Here you can add them when they have the same radicand, but you can't add them when they don't. So I have to make this into, now I know it's got to be a 6, otherwise I can't add it. So this is going to be 9 and 6, 3 radical 6. And I'm going to add that to the radical 6. So now I'm going to add the radical 6 that I had plus the 3. So my final answer is 4 radical 6. Okay, so let me do another one. How about I had 2 radical 5 plus radical 45. Okay, so this one's simplest. I can't do anything with that one. But this one could become radical 9, radical 5, which is 3 radical 5. So now I'm adding the 2 radical 5 to it. So my answer is 5 radical 5. Okay, let me just erase. I'm just going to do one more. Erasing very well. Okay, let me just do one more for you. Okay, so let's say I did radical 300 minus radical 27. So now I have to change both of them. Okay, so this one I know is radical 100 radical 3, which is 10 rad 3. Let me just erase that other part. That was silly of me. So that you can see what I'm doing here. Okay. And then this one I would make radical 9 radical 3. So this would become 3 rad 3. So now I'm just going to subtract and I would get 7 rad 3. Okay, so you have to have the same radical. Sometimes you might have to change both. Sometimes you might only have to change one. Depends. So that's for adding and subtracting. For multiplying, you know what? I'm going to stop my video again here because I think I'm going to run out of room.